nomenclature. Okay, so let me give you one more nomenclature. Actually, this is something Muhammad Umar had a doubt with. So I'm going to write the question down. CH3, CH2, CH, CH2, CH, CH2, CH3. Here we have CH3 group attached, and here we have CH2, CH3 group attached. Okay. So this is the question. You may try it. First of all, we know the functional group. We know the unsaturation. You will tell me the parent. E unsaturation is AN. What will be the parent? And then the substituent.
Pentane is the pent is the parent.
Pent is the parent.
Sorry, hept. Seven.
Hept is the parent.
Substituent is 1, 2, 3, 3 dimethyl.
No, ऐसे नहीं. You write the question. Na? Don't look here and tell the answer. Write the question. Okay. Write this, and after you have done, you highlight the parent, and after that you circle the substituent, and then tell me. Okay. अभी एक क्लास हुआ नहीं है आप लोग आईयूपैक नॉमेनक्लेचर सीखे हुए देख देख के आप लोग को नाम बताना है आराम से स्लोली ओके व्हाट हैपेंड substituents में बताइए what are the two substituents there are two ना
So dimethyl and methyl.
where is dimethyl tell me dimethyl and methyl कहाँ से होगा
sorry ethyl and methyl I'm sorry
यही हम बोल रहे हैं आप लोगों को यार fine so we have two substituents we have ethyl and we have methyl all of you agree yes or no why I'm not hearing other voices Mariam Reba Abhinav Atif
yes
now you tell me where I will number from should I number from this side that is should I start numbering from left to right or right to left
I believe right to left
okay now why is that but whatever we have learned till now both of these things are fine yes or no
sir alphabetical order of substituent
so whenever you get a confusion in numbering like everything seems fine everything seems same lowest locus is not working then if you have confusion anywhere then alphabetical order keep in mind alphabetical order even if you have confusion like if you have double bond and triple bond then it is written en why because en is e which is alphabetically before and y is alphabetically after that is why whenever we are writing something which is having double bond and triple bond then we write it as E9 in the unsaturation rather than INE okay so yes we'll start from here according to the alphabetical order this is 1 2 3 4 5 6 and 7 so methyl is in 5th position ethyl is in 3rd position and this will be named as 3-ethyl 5-methyl heptane okay Okay, so write this down. No, don't write this down. Just let it be here. And we will be moving towards the preparation of alkene. Okay, we'll be moving towards the preparation of alkene. Okay,
Sir,
so
can you
starting
tell
with
me lowest locant thing? Lowest locant. What does it state?
rule. No, I don't remember per se what is it. Remember what it says. If you want to ask me that, but think about it like this: there is only two way of numbering any main chain after you have identified it. Either you can go one way or the other way. There are only two ways, and in one of those two ways, the substituent will be summing up in the least number. The sum of the position of substituents will be the least, and that is the lowest locant rule. What it represents and tell. Okay. If you want the exact statement, you can just Google it now. I don't remember the exact statement. Okay, next is the preparation of alkenes. In preparation of alkene, the first method of preparation is halogenation. First method of preparation is halogenation of. Why am I writing halogenation? Sorry, hydrogenation of unsaturated hydrocarbon. Now, in this simple reaction, you will have multiple bonds here. You will react this with hydrogen in the presence of some catalyst, PD, PT, or nickel, and they will give you the surface for the reaction to happen. Okay, they will give you the surface for the reaction to happen. One
So what is
hydrogen will add.
PDPT MI?
What are these? You
Catalyst?
tell me.
Catalyst?
They act as a catalyst.
Okay.
They act as a catalyst. But these are elements, PD, PT, and nickel. Okay, these are element, and they
Platinum and
generally,
nickel.
they generally give surface. So we powder it, and then we put ethyne here, and then we put hydrogen here. So hydrogen, it gets the bonds, HH bond, it kind of breaks, and different hydrogen molecules, they have some affinity with this metal atoms, and they stick like this. Then comes the CH2 double bond. So these hydrogens are poking so that it directly gets attached to the carbon atoms, and the pi bond breaks. Okay, so they act as a surface and also catalyst. So you can have any R group, if any carbon, R1, R2, R3, or R4. You add H2, all of that, those parts will be consistent. Those are alkyl groups. You will just add a hydrogen atom on carbon. Nothing else. Now, if you have, let us suppose, CH, triple bond CH, then I will add hydrogen in the presence of any of these metals. Just take PD. So first of all, what is going to happen? You will get CH2, double bond CH2. And if the hydrogen is in excess, then you are going to get one more reaction will happen, same reaction, and in which you will be getting CH3, single bond CH3. So directly I can write, if I have an alkyne, then I will need 2 moles of hydrogen, some catalyst, to get CH3 and CH3 bonded with a single bond. Next is some remarks regarding this. This is also known as catalytic hydrogenation. Since we are using PT, PT, and nickel, these are catalyst hydrogenation. Next is there's a limitation here. The limitation is that we can't prepare methane by this method because methane has only one carbon, and for unsaturated hydrocarbon we need at least two carbon. Okay, we cannot have bond between carbons if we only have one carbon. So the problem is methane cannot be prepared. Prepared by this method. Okay, methane cannot be prepared by this method. I hope you guys have copy. So just for practice, write the major products.
Yes, scroll up. Just a second.
Want to write this?
Make
Okay, I'm giving you 2-3 minutes. Write this down. These questions and write the product for all of them. Don't send the answer. If you are done, just let me know if you're done. Okay. Are you done with all of the answers, Mohammed Umar?
No, sir, no.
नहीं तो पहले उसको कीजिए ना. Like that is more important.
Except, but it is, I mean, is it correct?
Correct.
No, it is.
Done, guys? Yes or no? Yes, Maimuna,
No,
Razan, Abhinav.
on the last one, sir.
Last one. Okay. What about others? Yes, I'm asking something. What about others? Maimuna, Razan, Abhinav, not done. Atif?
Done, sir.
Okay, Maimuna is not here. Mariam is here. I'm sorry. Okay, Mariam, you're done? Reba? Okay. CS3, CS2, CS3. Okay, so all of you are done. Like it's the simplest question that you can get an alkene to write the product of hydrogenation reaction or catalytic hydrogenation. Okay, so you have written the question. Check the answer. Okay, any doubt in here? These questions A, B, C, D? No doubt, right?
No, sir.
No. Okay, fine. So write the next. That is second method of preparation from alkyl halides.
Do we have to write it?
No, no. हम ऐसे बोल दे देते हैं. Write it, but that is just because it is in my tongue. From alkyl halides. You don't have to write anything. What are alkyl halides? Alkyl group.
Which form of halide?
Attached with halide, halogen. Is R bonded with X. R bonded with X. In this, there is first reaction. Wood's reaction. This is a name reaction. That is why it is important. It is a name reaction, and all of the name reactions are going to be important. Wood's reaction. Okay. Wood's reaction. So we will write first of all the general reaction, how it happens, and after that we will look at the mechanism also. We'll look at the mechanism. So in Wood's reaction, 2 moles of haloalkene or alkyl halide, it reacts with sodium in the presence of dry ether. The presence of dry ether, and then there's 2 moles of sodium also. These two form a bond. Okay, so mainly we write the, we'll get RR plus 2 moles of NaX. So if I have CH3X and also I have 2 moles of CH3X and there are what? 2 moles of sodium. Okay, in the presence of dry ether, what happens? They form a bond. They form a bond, and this CH3 attaches to that CH3. Okay, it's very simple. You will get double the number of carbon atom as compared to the alkyl in alkyl halide. When alkyl halides are treated with sodium metal in the presence of sodium metal in the presence of dry ether, it leads to formation of alkene with double the number of carbon atom double the number of carbon atom as in alkyl group of alkyl halide. Alkyl halide. So simply, if I'm writing a few reactions, okay. DE means dry ether, so you are going to make CH3, CH3. If I have, let us say, CH3, CH2, chlorine, the presence of sodium is going to give you dry ether, and then you are going to get CH3, CH2, CH2, and CH3. Okay, so you are getting double the number of carbon atom, but the important point is that which carbons are reacting? The carbons which are present, which are attached to chlorine, those carbons are reacting. So if I have something like this, CH3, CH, CH3, and here I'm having chlorine, then there will be another molecule like this, right? There will be another molecule similarly. So I'm writing it like this: CH3, CH, CH3, and chlorine. So sodium will be reacting with chlorine, right? Like this, and these are the two carbon atoms that will be forming bond. And in the presence of dry ether, you will be getting CH3, CH, CH3, and it will be bonded with CH3, CH, CH3. Okay, so please understand which carbon atom is forming the bond. The bond formation is happening between those carbon atoms which are attached to the alkyl halide, Okay, so important note here: the carbon-carbon bond, in product is formed between those carbons that are attached to halogen in alkyl halide. Okay, so understand this point, yes or no, guys? Tell me.
Yes.
Will you be able to form products now? Will you be able to form products? Yes.
Yes.
What
Sir.
happened? Okay, fine. Sodium in the presence of dry ether. Okay, try to write the products for these three.
Yeah, so can you zoom out? Scroll a bit up. Okay.
No, you have to write the question. No, other people have to write the question. Done?
Yes, sir.
What about others? Is Mariam done?
1 minute, sir.
Okay.
Done, sir.
Okay. So for this, I will give you one suggestion is to not to look at beauty, but look at utility here. So it's no shame. What I do, I make 2 of each. Like I have this reactant now, so I will make it twice like this. CH3, CH2, CH2. Then make again CH3, CH2, CH2, and join the carbons which were having bromine. Okay, that's it. Now here I will not. I will draw twice. Yeah, correct. I will draw twice. Okay. Then I will draw this once more, and I'm connecting the carbons which had bromine here also, or the halogen atom here also. I'm going to connect. Draw it like this. I'll again draw it like this. I will connect the carbon atoms that had bromine. Okay, easy. So all of you have got same, yes or no?
Yes, sir.
Okay. So moving on to a point in which, let's say, a problem here is the problem. What is the problem with these type of preparation is that we can only prepare even number of, we can only prepare alkenes with even number of carbon. Alkenes with even number of carbon atoms. Okay, but what if we try to make a molecule such as CH3Br, okay, CH3Br plus CH2, sorry, CH3, CH2Br, okay, and then react this with sodium in the presence of dry ether. So what can happen? This Br and this Br can form NaBr with sodium, and both of these two, CH3Br, CH3 and the CH3CH2, they can react with each other to form propane, that is 3 carbon atoms. But it quite does not happen like that, because we don't have only one molecule of CH3Br and only one molecule of bromoethane and bromomethane. We have million molecules of bromomethane and bromoethane. So what can happen? Yeah, this type of reaction can also happen, and there can be self reaction with CH3Br reacting with CH3Br and CH3CH2Br reacting with CH3CH2Br. So there will be multiple products that I will be getting. For example, if CH3Br reacts with CH3CH2Br, then I will be obviously getting CH3, CH2, and CH3. But what can happen? CH3Br, 2 molecules of CH3Br, that is bromoethane, they can react with each other and they can form CH3, and then you have bromoethanes. 2 molecules of bromoethanes can also react because they are in the same container, and they will be giving me CH3, CH2, CH2, and CH3. So now what we have done, we have made propane, ethane, and butane, all of them. Now separating these items will be very difficult. So if I take a mixture of haloalkane, I was trying to produce this. Okay, my aim was to produce this, but we saw that there can be reactions, self reactions also, that is leading to the formation of other product, that is these 2 products. Hence, if I take two different haloalkanes are taken, then it leads to formation of products that are difficult to separate. Okay, that are difficult to separate. Now, Next is the reaction with zinc in H plus, or the reduction of haloalkene. So we are just in haloalkene only. So as the first method, that is the Wurtz reaction. The second method, that is B, is with reduction. So in reduction, we are going to use, we are reacting haloalkene with zinc in the presence of H plus, and it is going to give me RH, that is a symbol for alkene, plus you will make HX. Plus you are going to make HX, and zinc is acting as a catalyst. And here we have X only, chlorine, bromine, and iodine. Chlorine, bromine, and iodine. So the reactions I can write as CS3, Cl reacting with H plus in the presence of zinc, and it is going to give me CH4. One hydrogen will be added, plus you will be making HCl. You can also have zinc in the presence of HCl. Okay, so simple reaction with zinc in the presence, simple reaction with hydrogen H plus in the presence of zinc. Okay, right, next, that is decarboxylation, rather from carboxylic acid. So first method of preparation was from unsaturated hydrocarbon. Second is from alkyl halide. We saw two methods, Wurtz reaction, and then we saw reduction. Next is from carboxylic acid. From carboxylic acid. So in carboxylic acid, what happens? We take one carboxylic acid and we react that with soda lime. Soda lime is the mixture of NaOH and CaO, that is sodium hydroxide and calcium oxide, and we heat it, and then alkene is formed. So let's write the when carboxylic acids are treated with carboxylic acid are treated with sodium hydroxide, they form sodium salt of carboxylic acid. So carboxylic acid mean I'm just writing C acid, okay? Sodium salt of C acid, that is carboxylic acid. On further reaction with soda lime. Soda lime is the 1:3 mixture of sodium hydroxide and calcium oxide. Reaction with soda lime at 630 Kelvin leads to formation of alkene, leads to formation of alkene with one carbon less than the number of carbon atoms in carboxylic acid, in carboxylic acid. So for example, if you have RCOONA, first of all, you will have carboxylic acid, RCOH. You will treat this with sodium hydroxide. So you will form a salt, that is RCOONA. Further, what you're doing, you're going to react with the sodium hydroxide and CaO. So NaOH, sodium hydroxide and CaO at 630 Kelvin. And this will give you RH. This is going to give you RH. What is RH? RH is this alkyl group attached with one hydrogen atom, that is alkene. Plus you are going to get Na2CO3. This is the byproduct. This is the byproduct. Okay, so if I start with, so directly you can also write this type of reaction: CH3 COOH plus NaOH in the presence of CEO. So what does it mean? We have sodium hydroxide, we have sodium hydroxide, and then we have CO. तो सोडियम हाइड्रोक्साइड से पहले आपका क्या बन जाएगा? RCONA बन ही जाएगा, है ना? You will get RCONA, the sodium salt of carboxylic acid. Then you will have this combination. ये तो खत्म नहीं होगा. This is not going to completely finish, right? Sodium hydroxide and CO is already present, and you have also RCONA. Then you are going to directly form CH3, and one more hydrogen will join, so it will become CH4 plus you will get Na2CO3. So here we had 2 carbon atoms. Here we have only product, only 1 carbon atom, only 1 carbon atom. So, for example, if you have some ring type of structure in COH and you just want a cyclopentane, so you will react this with sodium hydroxide, presence of CaO, and you are going to get a cyclopentane. As simple as that. You will be reducing 1 carbon atom. Okay, so from butanoic acid to propane, butanoic acid to propane. So write this down. This method is known as decarboxylation. So there is another decarboxylation reaction that is from Volbus. Please write what this reaction is known as decarboxylation. It's known as decarboxylation. Right. So understood this reaction? Yes or no, guys? Tell me. Yes, all of you understood? Okay. So right next, coal-based reaction, or coal-based electrolysis. This is also with carboxylic acid. This is also known as coal-based. Coal-based electrolysis, coal-based electrolysis. So first of all, let us write the statement. When an aqueous solution of sodium or potassium salt of sodium or potassium salt of carboxylic acid, carboxylic acid is electrolyzed, then alkane is formed. Then alkane is formed with twice the number of carbon atom as present in alkyl group of acid. Okay, so this is very important. Whenever I'm saying, you will get the product which has twice the number of carbon atom as the alkyl group of acid, That means if I have RCOONA, sodium or potassium salt of carboxylic acid, and I treat and I electrolyze it, so electrolysis will happen, and you are going to get R, which is bonded with R. So not RC. What is the alkyl group? This is the alkyl group. So twice the number of carbon atom as in alkyl group, So this is what you are going to get, R, plus you will get sodium hydroxide, get CO2, and now you are also going to get hydrogen gas, which will be liberated out. Okay, fine. Now this, what happens in this reaction? So electrolysis, there will be anode and there will be cathode. First of all, we know that RCOONA can easily ionize into RCOO negative and Na positive. Okay, and Na positive. Now, whenever you have a cell, so there will be electrolysis happening. So you will have some cell. So there will be anode and cathode. So there will be some reaction that is happening at anode. And at anode, what happens? Only oxidation happens at anode. Oxidation means loss of electron. So who can lose electron? Tell me guys, are CO negative can lose electron or sodium will lose electron?
Sodium.
Which will lose electron? CO negative or Na positive?
Cyan.
Na to nahi hai na lekin. Can you see that? Sodium is not there. Sodium positive is there. Now you tell me, which has the tendency to lose electron? A negatively charged thing or a positively charged thing, which will give you electrons more easily? Which will give you electrons more easily?
CO negative.
Yeah, correct. CO negative is going to give you electron more easily. So we'll have R COO negative. Okay. And it is going to give you, we'll take 2 moles of this, and each COO negative will give you 2 electrons, and that will make each of them neutral. So you will get R C double bond O, whatever type of bond is present here, like this RCOO, and that will be neutral. And this is very unstable. Why? Because oxygen, it is not having its the octet is not complete now. The octet is not complete now. So what it will do, it will take up the electrons. It will take up the electrons that is present in the bond, and it is going to form. There will be R. There will be another R. They're going to form a bond. Plus, you will get 2 moles of CO2. So this is how you are going to form CO2. Then you have at cathode. Now in cathode, what happens? In cathode happens reduction. In cathode happens reduction. In cathode, we get reduction. So reduction will happen of 2 entities. The sodium is also going to get reduced, and there will be water molecules present, that is aqueous solution. So water molecules will be present, and that is also going to get reduced. So what happens? Mostly water gets reduced, H2O plus 2 electron. They will eat up the 2 electron because it is reduction. And what are they going to form? They are going to form 2 moles of OH negative, plus they will be forming 2 moles of H free radical. Then this 2 H free radical and H free radical, they will be combining together, and they will form H2 gas, and that will be liberated, and that will be liberated. Okay, that will be liberated. Now when you have this OH negative, okay, so one more reaction can happen that is not happening in cathode, rather it is happening like this. Na positive plus OH negative will be present. That means you are going to form NaOH, right? You are going to form NaOH in the aqueous solution. Okay, so these are the reactions at anode and cathode. So the main starting point, though, like what I want you, or I want all of you to remember is, this part. First of all, you will ionize the sodium salt of carboxylic acid, and after that you think at anode oxidation, cathode reduction, that you can obviously remember. Anode oxidation, cathode reduction. Okay, anode oxidation, cathode reduction. Then you think which of them can give electrons. So obviously sodium positive is positively charged, it will not give electrons easily. But CO negative, it is negatively charged, it have to remove its charge, so it will give the electrons more easily than sodium positive. Yeah, if I compare sodium ion and CO negative, then obviously sodium is going to give electron easily. But here you have sodium ion and not sodium metal. Okay, Muhammad Umar, you were talking about sodium metal. It has a tendency to give electron, but sodium positive, it is positively charged, it does not have a tendency to give electrons. You understand the difference, Muhammad Umar?
Yes, sir.
Yes or no? Okay. Now again, here also, when we are breaking this CO bond, CO2 bond, then you are forming the carbon-carbon bond. The carbon-carbon bond is formed between those carbons which have the carboxylic acid group or the carboxyl group. So if I write major products, okay, write major products. So this is your homework. Okay, so I'm combining all of those reactions that we have done till now. So you have to tell me what do I have to use. You have to tell me what do I have to use in the reagent. Okay, so these are the 4 reactions. That is homework for you guys. Okay, so write this down.
Sir, can you forward me your hydrocarbon notes?
Ray, you asked Nishka sir for the na. You send him the email, he will share it with you.
What's that?
Hydrocarbons with a note. You asked Nishka sir.
So I've already asked in the morning.
What did he say?
No reply. He said he will be giving, but till now he had it.
Actually, like making notes, it is going to take a lot of time. Now you understand that, right? If I have to like make everything PDF.
No, the link that you sent yesterday.
Link. Okay. Yesterday's one. Okay, fine. Hydrocarbon. You wrote the questions, all of you, yes or no?
Yes, sir.
Okay. Umar, I have sent you the link. Please